Let us see more examples. Okay, so here you will see a very long question, but this is of the typical length of a thermodynamics question. Okay, the lighting requirements of an industrial facility are being met by 740 watt standard fluorescent lamps, but the lamps are close to completing their service life, and they need to be replaced by their 34 watt high efficiency counterparts that operates on the existing standard ballast. Okay, ballasts are some devices that ensure that the light can be stable, and during the startup it can get to the brightness as soon as possible. Okay, the standard and the high efficiency fluorescent lamp can be purchased in the quantity at a cost of $1.77 and $2.26 each respectively. Okay, the facility operates 2,800 hours a year. Okay, and all of the lamps are kept on during operating hours. Okay, take the unit cost of electricity to be $0.105 per kilowatt hour, and the ballast factor to be 1.1. And there is some explanation about this factor. That means this ballast consumes 10% of the rated power of the lamps. Okay, that means the rated power, suppose is 40, then 10% would be 4. That means the ballast will also consume 4 watts of power to operate. Okay, so we need to determine how much energy and the money will be saved per year as a result of switching to the high efficiency fluorescent lamps. Okay, we need to also determine the simple payback period. What do we mean by simple? Simple means that we have neglected all of the factors regarding money. For example, the time value of money, inflation, etc. We have neglected all of these factors. Okay, otherwise the problem would be more complicated. Okay, and you can see, let me highlight some of the values here. We have 700 light bulbs. Originally it's 40 watts. Okay, and then it is replaced by a 34 watt high efficiency counterparts. And we also have the cost of each lamp. Okay, the standard lamp is 1.77 and the high efficiency is this one. And this facility, we also have the number of hours of operation to be this one, 2x00. Okay, so all of the lamps are kept on. Okay, that's some of the assumption that we usually made to simplify our calculation. We take the unit cost of this one, so this is also important. Okay, and then we have highlighted all of the values, and let's see how we can do this kind of problem. So how can we know the energy that we have saved? Okay, we calculate this one first. Okay, well, we have assumed that both of them are operating in the same operating hours, and the only difference is that the rated power are different. So we don't need to divide this one to several steps. Okay, we can just write 40 watts minus 34 watts times, we have 700 light bulbs. Okay, in 1 year it operates 2x00 number of hours. Okay, and here this one should be watts. Okay, 40 minus 34, both of them are watts, so that this term should be in the units of watts. Okay, but we need to convert it to a kilowatt, so we need to divide it by 1000, and we also need to do one more thing, is that we need to multiply by 1.1. That's the ballast factor, because the ballast also consume 10% of the rated power. So we need to also multiply this power, and let me write it down the unit. It should be kilowatt hour per year. Okay, and after you have used the calculator, so 40 minus 34 times 700 times 2x00 divided by 1000 times 1.1, and we get this value. And first of all, we will take 4 significant figures, 12940 kilowatt hour per year, and then it will be equal to 12900 kilowatt hour per year. Well, that's a great amount of energy that we have saved. Okay, correct to 3 significant figures. Okay, how about the cost? Well, for the cost, we just talk about the cost that we have saved. Okay, so this cost saving, we just multiply this energy to the electricity bill, and here it should be per year. So after you have calculated this value, it should be 12940 times this one. You'll get 1358.7. So it will be 1359 US dollar, and that will be equal to this one, 1360 per year. Correct to 3 significant figures. Okay, we get this one. And we need to also calculate a simple payback period. And as I've said that, we have neglected all the factors like inflation as well as the time value of money. That means the interest of this money, so that we have the simple payback period. What I mean by the payback period means that after a certain time, the cost of choosing both options will be the same. We need to find out this value. Okay, how can we find out this? Well, as I've said that this one is the cost we save per year. Okay, but initially we have increased our cost because we have purchased more expensive lamps. That is a high efficiency lamp. So the money that we have paid, the difference should be this one and multiplied by 700. So that would be the extra money we have paid divided by the cost saved per year, so that we can find out the payback period, and it will be only equal to 0.25 year. Okay, let me verify this. 2.26 minus 1.77, okay, times 700 divided by 1359. We got this 0.252, correct to 3 significant figures. Okay, I don't take the 4 significant figure term because that's the end of the question. So we can see that, well, this payback period is actually attractive because we just use 3 months. We can balance the cost already. Okay, and you can see that in this case, actually, if we don't switch the kind of lamps we are using, then we need to pay a lot more money for the energy cost. Okay, and that would be the end of this example.